What's up, everybody? Welcome to the Dope and Tape Show. This episode is 69. Super. I can't believe I can't even talk. Like, I'm so excited to have you on here. We have the legend, at least here for Atlanta. I know tons of people know him worldwide for his fire pump knowledge. I call him when I'm stumped, and with everybody else that I would normally call, but if it's something super technical and I'm like, I got nothing, I call Wills, and I think everybody else does. This is Wills LaCrosse. He's here in Atlanta. This is his base, thank goodness. Because I use him a lot. So I'm so glad you're here.
Well,
And
glad to be here.
in my
Good stuff.
In my living room, hanging out.
Yeah.
So what got you started? Who usually in this industry someone brings you in?
Yeah. Well, when you go from the video industry, which I used to have video stores, they went down, and in 1999, while the video stores were in a decline, I had a call from an old friend, and he said, "Hey, I need somebody. My guy's sick. Can you go do a startup for me, a commissioning?" I said, "Yeah, sure, but I can't remember any of this stuff." And he said, "No, it's like riding a bike." So I said, "Well, where's it at?" And he says, "Oh, it's over in Africa." And I said, "How much does it pay?" And he says, $1,000 a day. I said, "How long will it be?" And he said, 3 days. I said, "Done. Just give me a plane ticket." So that's when I came back into the industry. When I got out of school, I went directly to work for Patterson Pump.
So where did you go to school?
I went to Georgia Tech and got an engineering degree. And when I got out, then I went to Patterson Pump and worked as their sales engineer for about 7.5 years.
Wow.
Until they fired me. But, that's another story. I went to work for another pump company for 2 years. And then after that, I went to work for a nuclear consulting firm to get my engineering, degree, satisfied. I said, well, I'm just doing sales stuff, and but I'm not using my engineering degree. So I went out and joined a firm that was nuclear consulting firm. And at that time, nuclear was going down and they wanted a pump guy. So I was their pump man for a couple of years before I got laid off.
Wow.
And then we got right on into video stores, was in video stores for years until that started to go down. And then I got this telephone call, which was, kind of nice. But the show was, go over there for 3 days, push some buttons, and it's all set, ready to go. I went over there, and they said, "We're glad to have you here. You can solve a problem for us." And I said, "Oh no, what did I walk into?" I was there for 3 weeks.
3 weeks.
Didn't mind. $1,000 a day. That's not bad.
Let's
And
go.
when I came back,
Whoa.
I told the guy, I said, if you feel like I did a good job, this is kind of a little bit more fun than, finding people movies to watch in the video store. And so he said, "Well, I will fix you up maybe 2 or 3 times a year, and I'll send you to exotic places to solve problems and be my service guy." And so I did that for 20 years until COVID came up. And so right after that, the video stores went away, and I said, "Geez, there sure would be nice if I could do this, stay busy in between these magical trips all over the world." And so then I started doing local servicing on fire pumps. And I figured that when I got up to that 100th pump, that maybe I could figure out how to really do a good packing. And so I am up to well over 6,000 now that I've done, whether it be packing or bearings or testing, alignment, just whatever.
So now
6,000.
6,000.
Over 6,000.
Wow.
So when I call him, when I have a super technical question, I will first tell him the pump that I'm talking about, because he's pretty much touched every pump in Georgia.
You would think so, but I have a feeling just in the Atlanta area, we probably have like 15,000. I think probably 15,000, maybe 20,000 in the state of Georgia. So I don't feel like I've even scratched the surface on all the pumps in Georgia.
Wow.
And some of mine have been repeats, for the annual testing and stuff. So, but if you like what you're doing, and I do, it's always a challenge. And I always like to hear of other people having issues with problems. I always, feel like there's more to learn and more to know. So
Yeah, at this point with repacking, do you take the bonnet off
now
every time?
when you're doing
Repack?
packing, it depends on the customer. Typically, yes. Yeah, that's what you want to do. If you're going to do a packing job, you want to take, we call it the top part of the casing, the upper casing.
Okay.
You always take the upper casing off. And the reason why is because you never know if there's going to be a rock in there. And you can evaluate the dimensions on the rings. You can see everything, so to speak. So if you have a choice, you always take the top head off. And getting the using packing pullers is very difficult to get past the lantern ring. In fact, most all the times
No, you don't do it. You leave that back ring in there.
Right. Well, it's a brass ring, that either brass or Teflon ring. They call it a lantern ring. And normally there's corrosion underneath it, and you cannot pull that out. So if you have a choice, if you're going to do a good packing job, you want to take the top off. Now, there are other types of pumps, vertical inlines, and you have Armstrong, AC, and SPP have cartridge mounts. So you cannot, it doesn't benefit you at all to take the top off. And so you will always use packing pullers on those units.
Oh, I didn't know that.
Yeah.
So how can you tell which is which?
It's fairly easy. The cartridge mount has a circle around the packing. So, and if you just look at it, you say, oh, if I take the top off, there's a piece of metal right there.
Yeah.
And so you say, well, it wouldn't do us any good. So, but it's fairly easy to determine the difference. And vertical inlines and vertical turbine pumps, they're all done by packing pullers. And
have you ever worked on a steam pump?
I've seen them.
You've seen them?
Yeah, but I haven't seen any that have actually been running. And steam-driven fire pumps. There's still some here in the state of Georgia. And,
I've heard of people seeing them.
Yeah.
But it's like, but they never.
Generally, the old mills and stuff. You have old cotton mill, old, some old mill, by a stream of some sort.
Okay.
But there's several that are still out there, but I don't think there's any running.
I've only seen some photos.
Yeah, but it cannot get too high of a GPM. I mean, I wouldn't think steam could push.
It's steam driven, so
about 500.
No, you can get just any size.
Really?
Yeah. Yeah, they had back then with the boilers and stuff, you could have 50 horsepower, 100 horsepower, 150 horsepower. Takes a lot of steam, but
it's a lot of steam.
At this point with like 6,000 pumps that you worked on, do you ever feel like you've gotten overwhelmed?
No.
Pump job,
now it's kind of fun when you find a problem that you've never heard before. I mean, that's kind of cool. That doesn't happen too often. Maybe it should. I wish it would.
Right.
But you'd be surprised that if you have a pump with just one spinning part, it's amazing how many different problems you can have with just one pump with just one.
I never thought about that way.
Well, so we could actually get a couple questions going for anyone who's joining. This is Will's LaCrosse, a fire pump expert from Georgia, over Brian's house. So we have everybody in the chat saying hi: Daryl, Amy, Chad, Tom, Mildred, Florencio, Annette, Bradley, Kenneth, everybody. NFPA 25 inspector, thank you guys for joining us. Don't forget to hit the like button. If you're not already, please subscribe. And if you have any fire pump questions or any questions at all, hit them in the chat and I'll read them out loud in between stories. Thank you guys for watching. Sorry, I just had to get that in there, guys.
No, absolutely.
No problem.
So, I mean,
when I was over there. No, I'm sorry.
I have one question. If we wanted to do a question.
Yeah, what you got?
Fire away.
Oh, I think his baby's going to sleep.
Yeah, my baby's going to sleep. So the question that I got from Steve was, how hot is acceptable for a fire pump packing to reach during churn?
Okay. Whether it's at churn or whether you're flowing water, doesn't matter. That whole area doesn't change in temperature. But temperature, typically, if it's 135 to 140 degrees, if it's too hot to touch, if you touch it and you go, ow, that's generally too hot. Now, will the packing be okay with it? Yeah, the packing, some of the packing that people use are good up to 600 degrees. So, yeah, that's a lot hotter than what we would want the packing to be. But typically the packing should be hot, but not anything over 135. 135 is a good, if you touch it, woof, it's hot. Then it's really, you need more lubrication in that area. Now, packing will achieve a packing set, and generally the packing will be cooler. You can always touch the glands. Some pumps are different. If you have a high speed 3600 RPM or big shaft diameter, you'll have more issues with your packing.
Oh.
But the temperature that you would have to worry about is anything over about 135, 140. But the packing can handle it. But it can get pretty hot pretty quick. In some cases, it can only take 30 seconds and you're producing steam at that unit. The key on packing is don't over tighten it. It's like peanut butter. You can get it in, it's hard to get it out. And so once you adjust it in, coming back out is tough. A lot of times it'll stick in and it'll overheat and it'll produce steam. Now, what do you do if it does steam? Say if you're doing a 10-minute run, if it steams up, turn it off. And then you get 5 minutes in, you say, okay, let's let it cool. When it cools, when it gets hot, it expands, and then you cut off the water supply. So you turn it off, let it cool a little bit, and you'll see the water start coming back up, and you'll turn it back on and run the next 5 minutes. And generally you're okay. That's kind of the way that, we look at it. But the less you mess with packing, the cooler it's going to run. I have more problems with the Navy guys that are used to adjusting it to get that 8 drops per minute. And that brings up another point. How much is the flow? How much is what's right? The NFPA says 1 drop per second, which would be 60 drops per minute. The Navy would go with 6 to 8 drops per minute. And that's an old standard, but that's with people fiddling with it. And with fire pumps, we don't want to fiddle with any of this stuff. So if you have a steady stream of water coming out and you're keeping the temperature cool, that's really more important than how many drops per minute. So avoid doing the drops per minute and just go with keeping the glands cool in that area.
Oh,
hopefully that answers the question.
that
I
is
think I gave you more
excellent,
information.
excellent advice. Well appreciated
Yeah.
for anybody that's watching.
Because
or
the
anyone
first
that's...
thing you see, like if a guy's like, oh, it's dripping too much, I'm just gonna tighten it.
Yeah, when you do that, you're in trouble.
So what do you do if you're like, oh, okay, it's too much water, you just leave it alone?
Well, there's a couple things you can do. Some of the pumps have little valves. They go, there's a little copper line on
Right.
pump.
I'm familiar
They
with
go
that.
from the top to the bottom. Aurora has some that are internal. Patterson has the little, the little, copper lines with the valves. If any of them have the copper lines with the valves, you adjust the valves first.
How would you go about doing that?
Well, if it's spraying out, is really when
When you turn and this is spraying everywhere,
okay,
and you're like, tighten them bolts,
yeah,
So,
no, you put a rag over it.
Yeah.
And then you worry about it later. Now, I can't tell you how many annual tests that I do, and I never touch the packing, and it's never seems to be a problem. And but if you start fiddling with stuff, you will. Now, if it's spraying out, you got to do something with if it's spraying out, if it's getting on the floor. And the way to go about it is if they have the little valves, you just turn off the valves and see if that adjusts it. Now, in saying that, you want to make sure that you're not pulling off of a ground storage tank. Those little valves aren't there for adjusting on packing. They're there for the. It's important to have that pressure line down to the boxes if you're running a ground storage tank, or if you have real low suction pressure, if it's down under 20 psi.
So that's something so the code says 20 psi. Like you should never test.
That's a whole different subject, but we can get into that. Yeah.
Okay.
All right.
Or if you want to talk about the other thing, or
no, that 20 psi is a good one.
So I teach everybody.
Okay.
Everybody, even the apprentices, anybody that I talk to about churning. I do free engineering classes.
Okay.
I tell them do not ever let it go, but below
the 20.
Right. Yeah.
It's good advice. Do I take that advice? No.
No.
Just about every fire pump that I test, if it's going below 20, I continue with the test and I do it. And I'm not too worried about it now. But if you're talking to employees or anyone in the company, yes, when you drop below 20 or 30, some municipalities use 30 psi. You want to follow that rule and you want to turn it off. Now, what are they worried about? They're worried about contamination of the water supply. And 20 psi or 30 psi at the pump flange, once it gets past the backflow preventer and on the city side, if you have 20 at the fire pump, that's going to be like 40 over or even 30 at the city line. So that's why I continue the test, but you don't want normal folks going anything beyond 20. Beyond 20 is enough to where you say stop it. And I agree with what you're saying. Now, most of the time that I'm testing pumps, I'm there to do the internal inspection and a retest and find out where their problem is and why they have a problem.
So you can't really stop.
No, I mean, I'll go down, I'll pull it down to negatives, and I've never had a collapsed pipe. I did have one pipe that blew out, but it was due to temperature, and it was a PVC suction pipe.
Yeah.
And they didn't have the casing relief valve set properly, and the pump room got up to about 200 degrees.
What?
And at the
water
got so hot that it melted the PVC pipe. And once the PVC got hot, then it expanded. This is underground, and it expanded and then blew out. And then you had about 1,500 gallons a minute going underneath the pump room floor, and the whole building started to sink.
What?
Yeah, it's crazy.
Whoa.
Yeah, crazy.
Jeez, I would freak out.
Yeah, one of those 6,000s.
That's wild.
Nuts.
That's a story.
Yeah. And that brings up another major issue with fire pumps. You know what causes them to goof up, and it's that little itty bitty case relief valve that's not adjusted properly.
So that's something I tell them too. So when they do a churn or any kind of test, you have to make sure that the case and relief is open.
Number one.
If it doesn't, you shut it off always.
Some pumps can generate steam within 5 minutes if that case and relief valve is not set. I did one that was had a discharge pressure of 600 psi. I think it's probably the highest in the United States.
600.
And it would produce steam in less than 1 minute if I did not have enough cooling water to keep
it has to be cool. I mean, it's pumping, right?
Yeah. But you have to remember that when you're testing a pump and you're not flowing any water, and you have a say 700 horsepower driver, it's going to generate a lot of friction. It's like a butter churn in the pump. And so it's sitting there, it's consuming about 150, 200 horsepower worth of heat. That's what it's generating. So if you don't let that water, the hot water out and let cold water come in to cool the pump, it can get your temperatures way up really quick. And
what are some of the like if someone's going into a pump room and there is not a case and relief, is that okay in some cases?
No. Well, the only ones you won't have a problem with is slow speed, low pressure ones. And
would that be like a vertical?
No. Virtually you have to have a case and relief valve on every single one. But I have seen them to where the case and relief valve was stuck, and yet it would run for a while and it wouldn't heat up. But essentially, it's how many horsepower is the driver, and then can it radiate enough heat to keep the pump cool?
No, you're saying
so the vertical turbine. The vertical turbine doesn't need one, does it?
No, they really don't. They need like an air release valve. Yes. So when it comes on, it blows all the air out. But you're right. That's one one pump that doesn't need it because it has the cooling water.
You got me nervous because we just put one of those in. We had no casing relief, and I kept on asking.
No, you're good.
But it did have that vent.
So there are
and then when the pump shuts off, that vent allows all the water to come down and out, so it's always empty right there. Yeah, it's kind of scary. Right. And it's just
and some of those, was it an electric, Bobby, or what?
Yeah, 300 psi. 1,500 GPM.
So if it was electric, then they have those little balls in there, nice non-reverse ratchet at the top.
Oh yeah.
And they normally make a lot of noise, and you hear a lot of clunks going on. You say, "Aye."
It's this one sounds great. Now we put it together. Patterson came down, helped us put it together, and we put all those bearings in at the end. It was It was pretty cool. It was cool to watch. We had to build
Yeah,
it
it's
in the
good.
room because we couldn't crane it in.
Oh my goodness.
Really?
Now, how tall was the pump?
I
How many
want to say
feet
it went to, I want to
shaft?
say it was like 20 feet, 19 feet. We had eight.
That's
We
pretty
had
good.
eight. We had eight balls.
Bowls.
Yeah, eight of those on there, and then
Yeah,
we had
impellers. Yeah.
two
Right.
flange pieces that were probably 7 foot, and so we had to put it down and put it all together. Two chain falls, and then lower the second one down and connect it to the next one. I got videos of the whole thing. It was crazy. It was crazy to do,
Yeah. Man.
and
That was cool. Did you
it runs
assist in
good.
that?
Yeah. Oh yeah, I was there.
Oh,
I mean, I was general foreman of the project, so I more or less watched. I
yeah.
was
Yeah.
running around.
Shame on
There was
them.
20 other guys on the job that day, so
Jeez.
there was
Uh,
we had one sprinkler fitter in the room, so for me to just hang out there all day, I took a lot of photos though of that whole thing happening.
Did you have to give anybody any almonds? Y'all take lunch or? So let me tell
On
you a little bit
on
about
that job we took break.
yeah,
On that job we took
yeah.
break. Yeah. On a big job
So
we take break.
Bobby, so when he's general foreman. So when
yeah.
his apprentice or anybody working under him, he doesn't let anybody stop for lunch. And then sometimes he has a box of crackers, like
Yeah.
saltine crackers, individual. From what
Yeah.
you
Yeah.
get
Yeah.
it for your
Right.
salad at a
Right.
restaurant, he has a
Yeah.
bucket of them.
Okay.
So if someone complains to say, "Here's some crackers, keep working," he does that to everybody.
The slave driver. Yeah.
Yeah,
Yeah.
That's good.
yeah.
Yeah.
No, we take
Well,
breaks.
it's
He's lying.
kind of
He's
funny,
lying.
Bobby, but yeah, I'm kind of,
Partially,
yeah,
not.
I'm kind of the same way. When I start working, I will not stop for lunch either. And so it bugs me when I'm on these particular jobs where they're taking off for lunch. I said, where did everyone go?
Right.
And I said,
Yeah,
oh,
man.
good.
It's
Now
like
I can get some work done.
yeah. Oh, I'm the same way. Just let's get it done and go home.
Now, have we gotten any more questions? We should be getting tons of questions, huh?
I know, but
Yeah,
I'm so intrigued with you guys. The thing is, it's crazy. There's a million things I could read right now. Where do you want to start?
Okay.
I don't know if they're questions though. These ones are like stories. You guys are
guys,
gonna
who else has questions?
ask
Come on.
questions. Let me see this phone can go.
Well,
So
we
over
have
here.
stories
Oh,
if you
so
want to
he
hear
said that
overseas
this
stories, I
guy's
have.
saying the code book, NFPA 25 inspector says the code book says it can't get hotter than 120 degrees. That would
That's good. Yeah, that's a good rule. Yeah. Now, if it's yeah, so let's go with 120. That's fine.
if it's producing
And
steam, I'm failing it because the packing at that point is 9 out of 10 shot.
Do you agree with that?
if it's producing steam, what was that?
If
If it's
it's
producing
producing
steam, I'm
steam,
failing it because the packing 9 out of 10 is probably shot.
Um, it depends on how long it's been doing it. I've been at commissionings to where the packing came in, kind of tight from the manufacturer, and it produces steam. If you turn it off and loosen it up, you shouldn't have a problem.
so when you
But
say loosen up, you mean by the
yeah,
breath.
loosen up the gland bolts. The little
Do
gland
you
bolts.
loosen them sometimes?
Yeah, yeah. It depends. Sometimes I arrive at a job site and someone has already, pressurized the pump and it was leaking too much and they adjust the nuts, which you really should never do.
Anymore.
Yeah, you don't want to adjust the nuts unless the pump is running. Now the steam thing, you could actually pull out the outer ring of packing and look at underside, and if it's glazed, well then it's toast. So it depends on the type of packing that they're using. Some of the pump manufacturers use Teflon and impregnated. Some use graphite packing, and the graphite packing is much cheaper than the Teflon, and you'll have more issues with different types of packing that they use. The Teflon packing, if you steam it, it'll glaze, and it looks like it loses all its lubrication qualities. And when you press it in, it won't do anything. It'll just allow the leakage to come right on through. But when you pull out a ring and then you turn it to where it was running against the shaft, it looks like fish scales. So you know it's toast.
Okay.
Right.
You want some lemonade?
Yeah, sure.
All right, so he's
Thank you,
saying
sir.
that has anyone seen
Yeah.
a low pressure switch that looks like a sensing line that can turn off the pump?
All right, say that again.
Has anyone seen a low pressure switch that looks like a sensing line and it can turn off the pump? I
off
haven't
the
seen
pump.
that. A sensing line, pressure
Usually the
switch
sensing lines for turning on
that
the
can
pump.
turn off the pump.
All right, so I've seen it where they have a valve with a sensing line that goes back to the suction, but that's a suction control valve, but it's not connected electrically to anything. Now, why would you want to do that? You could have that set up to where you could turn it off, and again, it goes back to your 20 psi.
Yeah.
Where you, but if you have normally they do it with a control valve, which is interactive. In other words, if the suction pressure, it'll regulate the flow at 20 psi. So it'll allow flow to go into the system to fight the fire, but it won't turn off the pump. It just kind of regulates the flow, and it'll stop the volume of flow to maintain that city pressure of 20 psi.
Yeah, he says we have no. Steve says we have pumps that have pressure sustaining valves. It's kind of like what you said.
Pressure
Kevin
sustaining
says never
valves.
use Ready Buffalo packing. Okay.
Oh my goodness. Ooh,
It's terrible.
no. Well, and I have to remember, I worked for Ready Buffalo
Oh.
back in early 80s, and Dr. Reddy was a good friend of mine. Now his packing was absolutely the worst packing you've ever had. It's horrible packing. So I agree with Kevin. Yeah, don't use Ready. If you have a Ready Buffalo pump, typically when I would do a startup on a Ready Buffalo, I would pull out their outer two rings and put my packing in. And
Yeah.
yes, it's not
Terrible,
good.
huh?
Now, the person that sold Dr. Reddy on those on his packing was a pump rep up in Chicago, and he loved that packing, but he's the only person that ever loved it. Dr. Reddy never would switch it. I tried to get him to switch it quite a bit, but no, he never would. Now, Dr. Reddy is no longer with us. He passed away last year. So,
Oh.
yeah, but he was
Now,
a good friend.
if you were to, how can you tell? Let's say that you got your 100 and you got your 200 from the readings. Okay.
Okay. I mean, discharge suction.
Yeah, right.
Okay.
You hook up your flow busters, you get your 100, you get your 150,
Okay.
and then in what cases can the pump still fail if you get your readings flow wise?
We have to remember that all you really have to get is your 100%. Are you talking about with the city pressure?
City pressure.
Okay, so if the city pressure goes down and you have to stop the test and you were at 101%, you can pass that pump.
Okay, I've heard that before.
So you can stop, and you did a successful test, and the city water is saved because it didn't go below 20 or 30, whatever that number is. And yeah, you're okay. And even with NFPA, they'll say, yes, you're okay. Now, if you're at 99%, no, officially no. Now, realistically, yeah, because you might be off a little bit it's a flow test, for goodness sakes. You might be off 4 or 5%.
Well, of course.
You can make a judgment call. Now, one thing that we're supposed to be doing when we do annual flow testing is where you have to generate two curves. One curve is the pump good, and the other curve does it meet the system demand, and that's a whole different curve. That's where you keep the city pressure in, and so whenever I do annual tests, I generate two curves: one with the city pressure and not adjusted with speed, and then the other one to compare the pump with what it was when it was brand new. Now, at least in the state of Georgia, no one checks it on to see whether it meets the original system demand that they designed the sprinkler system, and they should be. Now, I don't know about other parts of the country, but I have a feeling they're probably like Georgia, to where everyone's hasn't really been doing what they should be doing on their annual tests.
No, and I'm not familiar with the two curves. So when I would do it, I'll get my churn.
Yeah.
I get my 100%, roll right into my 150.
Right.
And then call it good.
No, you're good. And that tells you whether the pump is matching what it shows on the nameplate, right?
That's correct.
And that's 0, 100, 150. For the other curve, you're supposed to look at the placards on the standpipes and say, oh, this was system designed for 485 gallons a minute at 65 psi. That's what this standpipe requires. And you go catch all the other standpipes, and they're all different numbers. And then you're supposed to put the little X's on there. And if your city pressure drops from 80 psi down to 0 or 80 down to 20, you just lost 60 psi, and perhaps that design of that of the requirement on the placard is no longer being met. That's where if the city pressure drops from new to old, just because the city is dropping their pressure for whatever reason, then that's really when you need to check to see whether you're meeting the system demand.
Okay.
Because if you think about it, that's what we're trying to do. We're two things. One, we want to see if the pump is failing or the pump drops below that 95%. You have, a 5% leeway. And then the other part is the building protected?
Right.
And that's where the system domain comes into play.
Now, if you were to give some advice to someone who's just starting fire pump inspections, because they can be intimidating. There's a lot of pump, water's moving, it's loud, lots going on.
Yeah, you're right.
High voltage, like that can be super intimidating. You have tons of water being pumped out of the hoses.
Yeah.
Like, should it be intimidating to them?
I would say it was intimidating to me, that's for sure.
I mean, yeah.
I mean,
me as well. When I was an apprentice, I was like, whoa.
And then you throw in a diesel engine.
Yeah.
And then you're really
making noises and you can't shut it off.
Yeah.
Yeah.
I was doing even with experience. So the first I was over in Dubai doing a flow test on a big vertical turbine, just like one you were describing, Bobby. Only I was out in the open. It was a 5,000 GPM fire pump with about a 800 horsepower CAT engine. And I was scared to hit that start button. So I told the little Indian guy, I said, hey, Patel. He said, yes, sir. Yeah, yes, sir. I said, yeah, yes or no? He said, oh, that's a yes. Okay. Go ahead and start that engine.
Yeah.
And that little guy went over there and just pushed that button. I said, well, I'm glad I didn't have to start that one.
That's
It was
awesome.
funny though. But that particular unit, I actually caught the pump on fire.
What?
Figure that out. Vertical turbine with a gear drive and an 800 horsepower big CAT 12-cylinder engine. And, Patel came over and he says, boss. I said, yes. He said, pump is getting really hot. I said, it's okay. I was thinking it was packing. So I just I said, it's okay, Patel, go. You go back. Everything's good. And so we were taking more readings. And then Patel comes over, boss. I said, what, Patel? He said, but it's getting really hot. I said, I know, you already told me. Never worked. Next time he came over, he said, pump's on fire. I said, that's silly. You can't catch a pump on fire. Walked over there. Sure enough, it was on fire.
So the pump or the diesel or the engine?
Yeah, it was the it was right there where the packing is at.
Oh, that was on fire.
Yeah, so they got a fire extinguisher and sprayed it. They were worried they were going to get kicked out of the country because they started a fire at it was Dubai Power and Light. Oop, maybe I'm not supposed to say anyhow. But we caught it on fire. Yeah. And it turned out that there was a rubbing of the stainless steel shaft sleeve with a sleeve that was inside the motor. And those motors have oil in it. And the oil had bubbled up and flowed down the shaft. And it had gotten up to about 900 degrees and it flashed into a fire.
Wow.
That's crazy.
Wow.
That's super. That's hot.
Everything's good. We had to get a big crane. You talked about, taking one of those vertical turbines out. They're not fun. So we had to get a big crane, pull it out, and then fix it, and then put it back. Yeah.
So they also have pumps that they lower it underwater.
Yeah, that's what we're talking about.
Okay, so it's like that.
Yeah. It's about 20-foot setting. It's similar to yours, Bobby, that you were talking about. Only a lot bigger.
Yeah, that's huge. Would you say 5,000 GPM?
Yeah, 5,000. It was a big one.
So wow. Justin says they do the net pressure and flow not corrected, then the curve corrected to RPM and pipe size. When we commission pumps, we verify the flow and pressure matches the placards on the risers, like Will said.
Yep.
Got someone.
And so the uncorrected one is the one that you compare to your placards on your system demand points, and then the corrected one. You need it corrected because that's the way that the pump curve was actually generated on the nameplates. And those nameplate points, some of the pump companies they put NFPA numbers. They don't put the actual pump number on it, which was kind of confusing. But that's essentially what you're supposed to do. Just compare it to whatever it is on the actual pump nameplate.
People never check alignment
Now,
in Connecticut before an annual flow.
what was that? I didn't hear it.
Say again.
People never check the alignment in Connecticut before an annual flow. That's from Kevin. So you always check
I wouldn't
alignment
say they
before
don't
an
do it
annual
here
flow?
either. It never happens.
You're supposed to. Now, I didn't do it. I knew that you're supposed to, but that was somebody else's job. That wasn't my job.
Right.
Just because it's not easy to do and it wasn't fun, and you have to take those stupid coupling guards off. So I said, well, I'm here to do the flow test. So I would put on my report, the alignment is to be checked by others. And so that went for, I guess, about 15 years. I towed that line until finally the FM people came up and they brought up the alignment issue. And so then I got to thinking, I said, well, shoot, I'm doing seminars and teaching people. So I better do what I should be doing. And if it's not me, who is it? If it's not the pump guy that does the pump test, then who's going to do it? We don't have millwrights anymore. So that whole, that whole industry is gone as far as testing fire pumps. So now I will not test a pump annually without checking the alignment first. And what we're finding in the Atlanta area is, I would say about 60%, 60 or 70% of every pump that we test needs a realignment, which is just a sad state of affairs. But it goes back to when I first, one of the first jobs that when I was being trained in the field, I went with a pump rep and in Georgia here, and he showed me how he aligned it, and he got some banding material and said, here, we just put this stuff in here, and they just kind of look at it and do the straight edge. And so there wasn't any precision involved. And then unfortunately, a lot of the pump people in the state of Georgia that was installing things 10, 20, 30, 40 years ago, they wouldn't even check it. And they are the ones that are responsible for the equipment, for providing the warranties and stuff. Now, the contractor, the installing contractor, is the one that's supposed to do all this work. Back years ago, they would have millwrights working for them, but they don't do that anymore. And so no one really has been checking them.
Right.
So that's why we're finding that, 60, 70%, 80% of the jobs we're now testing, they're all misaligned. So it was a good thing that FM Global brought this to light. And if you have any FM Global guys out there that are insured jobs by FM Global, they will require you to give them a alignment report, or at least certify that the alignment is good.
That's what Steve's saying right now in the chat, is that his FM Global customers do it annually. He subs it out and they do a laser alignment for better reports.
That's good. Well, he should do that for maybe the first year and look and see how much that laser guy charges, and then do it himself. He could do that is just as easy as himself. There was a company in Virginia that came down to.
Do you hear that, Steve? You
Yeah.
need to do it yourself. What are you not doing
Steve,
it yourself,
you can do it
Steve?
yourself. It's very easy. When I do a seminars, one of the days is concerning alignment, and it doesn't take much to train someone, especially with a laser. Now, it'll take a little while for you to figure out the little tricks that people use, but essentially it's just timing. The procedures are there, and you just take your time, and bingo, you can be just as good as that guy that comes in and does it.
Yeah.
So, it's a tremendous moneymaker, especially down here. I would say that maybe 15 to 20% of what I do now every year is laser realignments, and I've been trying to get the sprinkler contractors to buy their own lasers. A few of them here in the Atlanta market have bought lasers. They would pay me to do the alignment, get them started, and then I've actually trained several of their folks to do it. It takes business away from me, but that's okay. They're adding value for their customers and adding skills for their workers. It's really nice.
That's very important. That's why we also we tell everybody anything, including getting trained or any certifications, to go ahead and do it,
And do it.
not to wait on their
Yeah.
company to send them to
Yeah.
get as
Let's go
much
and get
knowledge
it.
as they can.
Yeah. Yeah.
Yeah.
Yeah. If you think about it, um, where the problem comes in today is that now the couplings have to be UL listed. And before they weren't. And people were using Woods couplings, they were using Lovejoys, they were using other couplings that were real tolerant on misalignment. But the couplings that they're using today are UL listed, and some of them are very, very tight on their alignment criteria. The Rotex is the leading one. Most all the pump people are using them. And the Rotex, you have to get it within 5,000ths of an inch. And it is nasty. If you get out to 30,000ths on a Rotex coupling, you will shake that building all apart, and the pump will not last more than 2 or 3 or 4 years without causing bearing issues and vibration issues inside that pump room. So the couplings that they're using, that the pump people are putting on there, you have to get them really tight. Even the Patterson and the Falk coupling, Clark also has the same, Falk design. I think their patents ran out, so everyone copied them. And the Falk coupling, when you install it, you have to get it under 8,000ths. So even the Falk coupling is requiring people to get very, very tight tolerances on it. And you can't hardly do that with straight edges and dial indicators. You can, but it's the timing. It takes so much more time on it. If you use a laser, then you take a picture of that laser, and then you're clean as far as your responsibilities, and you can prove that you actually did a good job. It's not like you have the guy that turns around, spits, and says, "Yeah, it's good," and you have to take his word for it, right?
So how do you feel about I'm curious. So let's say the pump has a loop, and then what are your thoughts on flow meters?
Oh, flow meters, you can't trust them until you can verify them.
Well, they're never verified.
Well, what I'm saying by verifying, for example, I'm going to do a test on this Saturday.
It's calibrated and all that.
Yeah. Well, NFPA requires you to have it calibrated once
every year.
Yeah, or every third year
Every
if
third.
you're going to use them. The problem comes in, you're going to calibrate the meter and not the element. Now they say, well, the elements don't change, but in Georgia, we get a lot of corrosion buildup inside our pipes. So yeah, the elements change. And so you can calibrate the meter, but how about the element? Are you going to calibrate that? To calibrate the element, you got to take the whole thing out and send it to a test lab. So you can, run, if you can run a header with your regular hose valves, you run that on that third year, and then you can compare it to your flow meter results. And so you can kind of calibrate it in the field like that.
Ooh, they're screwed the one what we just did, because our flow meter goes back into the tank, no access to it. So how are they going to? We just did one on that turbine
Yeah,
we were
you're
talking
right.
about, and it's a tank
Right.
fed,
So,
and
yeah, you don't have a choice.
it goes back
Yeah,
into the
yeah.
tank, and you can run it. It's to save water.
Yeah.
It's green.
Yeah, you're not going to have a choice. You just have to trust it. And if on that third year, you can actually take that and you take the meter out and take the element out. But NFPA doesn't say that you have to take the element out. But I'm saying in reality, you have those two things to worry with. Now, there's ways around that, so to speak. But most of your flow meters that are installed are not reading correctly, and because they're not installed correctly. If you give it that 5 upstream and 3 downstream, or 10 upstream and 6 downstream, if you follow the procedures, some of them read very, very well, and they're very accurate. But most of the pump installations, the problem is that the fire pump is only this wide, and so the sprinkler fitters are just going to, folks are just going to put them in a loop, and that's not giving the flow meter enough room to straighten the water out and to read properly. So whenever I see a flow meter, and if they have a header as well, then I'm using the header. Now this weekend I have to test 4 pumps, and last year they actually installed a header because they were having issues with the performance. The pumps are 20 years old, And so the pumps were suspect, and several of the folks had gone in and said, you have to replace your pumps. And I said, well, it's probably not the pumps, it's probably the meters. So one of the meters that we were testing, it was going in a loop, and I just rotated them. We loosened up the Victaulic connections and we rotated it 90 degrees so that the taps were in a different position. And we got different results just from where the taps were at, because the water would swirl around and was concentrating on one side of the flow meter and giving us a different reading.
Wow.
So we ended up recommending that they put in a header line. They did. We tested all 4 pumps, and 3 out of the 4 were just fine. And
Wow.
so this year, I have a record of what the meter was versus our header line. So this year I'm going to use the meter and not have to put my hoses out.
Yeah. So
take advantage.
I think it was 2 episodes ago we had a pump question, and it was quite interesting. So when he flowed the fire pump with hoses,
Okay.
and then closed the discharge to the building,
Okay.
versus doing another same inspection with hoses with the discharge to the building open, he got drastically different.
Okay. So officially you shouldn't get a change, but will you have a little bit of a change? Yeah, but you have to let the
say
water.
80 psi.
Yeah, no, it's that should not happen. Now, if you think about it, you're deadheading all the water in the building. Okay.
Right.
But if you open up a valve and that building is 175 psi and you drop it down to 150, you're going to have some water come out of the building because it's going to match whatever that discharge pressure is. So when you're at the end of the pump curve, you're really low, and so all that water in the building that was at water doesn't go anywhere, but the pressure drops.
Mm-hmm.
And that's it, but it's a static pressure, so it really shouldn't change.
Right. That's what I was thinking.
Something else was going on.
What do you think?
That test?
Yeah, that's what I said. I think there was something else going on.
Yeah.
80 psi is a lot. I even reached out to an engineer friend of mine and said, "Hey, what do you think?" And she.
Now you could determine that. Take another pump, and you play with it. And if you're sitting there flowing water, and then you just open up that discharge valve during the test, you'll see that it shouldn't make any difference at all. Now, if everyone made 80 psi, then I want you to call me.
Yeah, yeah, that's something we've never seen.
Because I'll come out there and figure it out. And I say, "Oh man, something new."
Yeah.
Finally, it took 6,001.
Right.
The pump guru's gonna come to you. Steve says that FM told the customer no more flex couplings are allowed. Is that true?
Yeah, that is true. Now, remember that they're all flexible, every single one, even the ones that FM likes. But what FM is talking about is the ones that have elements. Woods coupling is, particularly. They had poor FM had they lost a lot of money. I think $30 or $60 million on two particular jobs, to where the coupling element sheared out, and there wasn't any metal behind it. So the elements melted or they sheared, basically due to misalignment, I think. Yeah. And the pump, the motor was spinning, and the pump quit working, and the buildings burned down. So they said no more, plastic couplings, or no more elements that don't have a metal backup. So if you think about the jaw coupling, like I say, they're all flexible. The jaw coupling, if the element deteriorates and melts, or is old and cracks and goes out, then you have metal backup. And now the Woods coupling is gone with FM Global, but the Falk coupling is a steel flex coupling. It has it allows some flexibility, but it has a steel spring, so those are acceptable. And see the other one, the Rotex. The Rotex is just like the jaw coupling, where it has a little flexible element. If you lose the flexible element, then it's metal on metal. I've had them to where on jaw couplings that the element was old and it's rubber, and it cracked and flew away. The alignment was horrible, and it was running metal on metal. And the customer didn't realize that, having a decibel level of 150 was they thought it was normal. And I walk in the pump room and I said, "What is going on?" I said, "Yeah, this thing should not be making any noise." And we took the coupling guard off, and it was metal on metal. And so they'll make a racket, but they'll still work. And
Wow.
so that's why FM Global came up with it. It was a good thing. Now, be perfectly honest with you, my opinion is that the Woods coupling is a great coupling, and those two locations to where the coupling sheared out were it's probably due to misalignment. Or I had one that the casing relief valve was turned off, and it heated up the pump to 300 degrees, and so the shaft was at 300, maybe 350. I don't know how hot it was, but it actually melted the element. The element got so hot that it just kind of melted, and it spun like it came all apart. And so it was misalignment plus the temperature hit that Woods coupling, and it failed it. So,
Jeez.
now
Wow.
I've had them
Great
with that
question.
case relief valve. It goes back to the
Yeah.
case relief valve. I had it to where there was one job where the fireman would call. The pump ran for 3 days.
What?
No one knew it. The alarms didn't go off. And when the firemen were finally called, because they finally had an alarm go off, and so they called and they came to the pump room. And fortunately, they had one of those temperature things, and they put a temperature thing on the door. The door was 320 degrees. The door going into the pump room. This is an outside door into the pump room. And so they went out, got all the gear, came back in, and then they blew open the door, and black smoke came out. They fired their fire extinguishers everywhere, and they finally found the pump in the corner, and there was not a fire. It was just hot. And the pump was completely black, turned the red paint black, and just sitting there steaming. And I got there about an hour later, and I looked at the floor, and it's all covered with white. I said, what did you guys do here?" They said, "Oh, we couldn't see anything with our equipment. It was just black as it could be." And so we just sprayed our fire extinguisher. So we couldn't tell where the fire was at. And then when we got to the fire pump, we realized that there wasn't a fire in here. It was just this thing was at about 900 degrees. And it was, cooling off at the time. But that's crazy.
Wow.
Like I say, that I think that was like 4,442. And I think that's
They're made to run
Yeah.
until they
it takes a
fail.
while. It takes a while to find one of those. But I'll be honest with you, that overheating with the case relief valve, I'll probably see maybe 10 of those a year. Yeah. That's a regular recurring fault, amongst it. Now, case relief valves, it depends on what area of the country you're in. Down here in Georgia, we have a lot of oxide buildup on the inside, and there's only one case relief valve that works in our area. Down in Florida, you might have calcium buildup, and again, you'll probably have one that works, and it's that designed by Clay Valve, the Clay Valve 55L. It's probably the only valve that I found that just works.
Right.
It doesn't stick. But you have the FWC. Patterson used it for 20 years, and they stick. That's my second choice. You'll have several of the other valves. Just about all of them will stick, just based on our water down here, and I'm sure in other parts of the country. So the case relief valves should be replaced if they don't. It's very, very important that
Yeah, I agree.
work.
I don't,
Yeah.
so I do not do field adjustments. I just tell
Yeah.
them to replace it.
Yeah, and that's it. I used to fiddle with them. I used to sit there and clean them out, and I'd say, "Oh, there's a little rock there. Oh, look at that. Oh, look at this buildup, man." And then I'd lose the spring, that was I'd
Yeah.
be looking on that nasty floor looking for the darn spring, and I'd spend an hour on that stupid thing. So I said, "No."
So I was in
If
a
it's
room.
stuck, I say,
Yeah,
just replace it.
yeah, absolutely. I was in a room, and at this time I guess I was senior level inspector, but there was another inspector that was above me.
Yeah.
And he went to go adjust it while the
Oh,
pump was
yeah.
running,
Okay, well, that's all right. You
and
can
then
do
he
that.
ran out of threads.
Oh,
So then
Yeah.
it's shooting water through there. I'm
Yes.
running, and
I see.
he's shutting off valves. He
Ooh,
adjusted too much.
too much.
Yeah, it's crazy. Well, the adjustments on them, typically, if you have one that's stuck and you loosen it and adjust it properly, doing your job, and then you turn the thing off, it'll leak. And so that's your issue. So nowadays, I will not touch them. I do the same thing you do. I'll put it on the report, needs a new case relief, and
Absolutely.
I don't even mess with them.
Pump failed.
Yeah.
Yeah.
Yeah. That's good.
Absolutely.
Mm.
Who's coming on next?
So
on
Steve's asking,
Thursday?
and this is a good question: should the fire pump
Okay.
go to an alarm or to a supervisory if it's running?
If it's running, my goodness, call the fire department.
Supervisory,
I would say, I would say alarm.
1,000%. You
Really?
would say alarm?
I would say alarm.
I like
So
alarm
I
too.
I think so I believe technically it should be supervisory
Yeah, most of them in Boston are. Like the fire pump running is
because
just a supervisory. But if it's
it's
running, it
not
should be an
an
alarm, right? Why is it running?
well no, because it's not an alarm indicating device technically.
I don't know.
So what a fire pump is doing on the sensing line is sensing water drop, water pressure loss, right?
Right.
But it's not a sprinkler head opening up. Sprinkler head is an alarm indicating device.
Yeah,
Now,
no,
will
I
they
hear
have
you.
will they have a flow switch somewhere in the line? If there's
Inside the pump?
no, this is
No,
out.
yeah, if there was
Yeah, so
something
the flow
flowing.
switch would be the fire alarm
Right. So
indicating.
if they don't have any flow switches, then do you think that they should use it as an alarm?
I do.
Yeah. Okay,
Yes.
good.
Yes, I do.
So that would be your caveat, and I would agree with you. If it was all supervisory, it would eliminate a lot of false alarms to the darn fire department because I
Yeah.
feel sorry for them. Yeah.
Does that mean for it to kick on, you can have a bad check valve, you can have all these things. So I really think, and I believe I don't know if it's in code anywhere. I'm not a 72 guy, but I believe it should be a supervisory. So supervisory is when someone touched something and
It
then
just the panel's
it
beeping
sends a
and the panel's just
supervisory.
beeping
Right.
supervisory. So
The trouble means
that
that
pump could be
there's
down there
something
running for
wrong.
3 days, and then it catches on fire, and because some people just go and silence that supervisory. Whereas if the alarm went off, you'd get some people
Well,
there to
that's
come
why,
investigate.
right. That's why training's so important. They need to know engineers, everybody needs to know the liability that they're taking when they hit that silence button.
The big money maker up in the Northeast is when the dry systems trip in the winter, and it doesn't, and something happens where the alarms don't go off, and the in-house guy just silences it, or he silences that low air signal. That's what it is. The low air signal will come in as a supervisory. In-house guy silences it. System trips. It's 10 degrees outside. See you later. That happens often.
Yeah, I can imagine. You guys have to worry about a lot of freezing. We do down here.
We definitely did recently in December.
Yeah, that's right. Oh,
Man,
it was amazing in January. I feel sorry for you guys.
we were all out there.
That was bad. Or it was good. It was either bad or good.
Well, it was, let's say there was so much. All right, so you don't know this story. So on that day, I rolled out to a high rise, pulled in a domestic line on the penthouse, busted 6 or 8 inch. It's going through the 27 floors,
Oh,
all through the parking deck and the
Okay.
atrium everywhere, right?
right.
So I go through and I've sold the inspection there, so I also know where all the equipment is because I walked it. So you had to go outside and shut off the main.
Okay.
It took us forever. We shut off the fire, we shut off the domestic, and then I leave and I turn left downtown Atlanta. There's this other high rise, alarms going off, and maintenance are running around. I turn left, and there's a parking deck that's just the dry systems.
Oh,
The
geez.
water's running, and I keep driving, and then there's another horns and strobes, and then I get a call from my friend who's a city of Atlanta fire marshal. He's like, "Man, the trucks are not stopping. We're filling up, and we're going to the next freeze."
Wow.
All
Yeah, it was a
like
mess.
it was crazy.
All right, we got a
That's
detailed. We
bad.
got a detailed
Well, it's
question.
never been that cold in
No.
Georgia
Yeah,
because the wind chill brought it down,
that was bad.
and it's
Yeah.
never been that cold ever.
Volt.
We learned that
I've
day,
never seen
boy.
you before. Volt. Yeah, we froze up here in the Northeast too. I worked around the clock to get everything frozen. Everything. It was -20. It was like -25 up here for a long time. So much stuff froze. We have
Yeah, he was inviting me up. I was like,
is
no
this a
way.
new
No
comp?
way.
I don't know if I've ever seen you before, Volt. So he's got a question. He's got a diesel that's throwing an overspeed alarm. It's a Clark diesel matted FD4 Metron. What's the best method for troubleshooting a faulty overspeed sensor on a Clark diesel? Clark is telling me to uncouple the diesel from the pump and hit the start button to check the RPM. Metron is telling me to check the overspeed contact, output 3 and neutral 11. Check for voltage above 12 volt and then I'll know the fault is coming from the engine. My thought is an uncoupled pump on a diesel would throw an overspeed because it's attached to zero load.
All right.
So
Is it but it is a Clark, so it's fairly new engine. What is the model number on the engine?
got the
Is it a
model.
4045?
He put Clark diesel matted FD4 Metron.
Okay.
Mated.
All right. Let's see if he can respond whether it's what size engine. Clark uses several engines. They have, John Deere engines. They have Perkins. In the past, they've even used Detroit diesel engines and some cats. So let's see which engine it is. But just in general, that overspeed switch, if it's on one of the newer engines that has electronic circuit boards connected to it, it's a whole different thing to diagnose. The older engines, which this is not, the older engines, the speed switch would actually go out, and then you could replace it. It was a mechanical switch, and you could swap them out.
It's
But the
5 years
newer ones
old.
that have, it's how many years old?
It's 5 years old.
Yeah, see, that's a new one. It would have electronic stuff. The Clark people are pretty good. I would listen to what the Clark people. The Metron guy is just saying, am I getting a valid signal? And you would know that if you have to reset it at the engine, because if the only way to reset, let's say to reset it, do you have to reset it? Resetting it at the engine. I can't remember whether you have to reset it at the engine too as well. But both those, he's done his homework. He's called up the folks.
He's saying
And
JW6H question mark question mark question mark. JW6H. Maybe that's the serial number.
it's probably a JU6H maybe. But
JU6H.
no, that would be a John Deere engine, I think. And I've had that happen a couple times where I've gotten the call repeatedly from some stores to where that alarm would go off. Never really did get to the bottom of it. It doesn't happen that often, at least with mine. And in fact, on that one particular engine that I'm thinking of, I haven't had that same call in a couple of years. So it might be just a one-off. But you're right. If when it spins up the pump is actually going to pull horsepower, and it really shouldn't be tripping that overload. I would say it's if it happens again, it's a bad circuit board. They can get a new circuit board for that, from Clark. But yeah, what a a very unhappy problem. I wouldn't like that.
Yeah, Clark is telling him to uncouple the diesel from the pump and hit the start button to check the RPM.
That'll do. That means that there's no load on it, and if it trips out, well then, I think that what they're trying to do is determine whether it's in their circuit board, in the circuitry, on their control panel.
The pump cranks, it runs for 3 to 5 seconds, and then it goes into alarm.
Yeah, that's not good.
No.
Not good at all. Yeah, I would suspect their circuit board. If you think about it, that the engine control panel, it's subject to a lot of vibration, and they have vibration isolators in between the control panel and the frame of the engine, assuming that they took out that little block of wood that someone's supposed to remove, from shipping.
Mhm.
And so there's a chance that maybe that little block of wood is still stuck up in between there, and that poor thing has been shaking like crazy for the 5 years, and it's finally wore out the darn circuit board, and something finally got loose. but I would have them, and check that and to see if there's a problem with the circuit board and the circuitry. But do what Clark says, and I think that would kind of expose it, because that means that it'll speed up if you don't have a load on it and it's tripping out on the overload, then there's something wrong. It might just be set wrong. The setting might have changed. That's not something that you can modify, but Clark should be able to figure it out. Talk to the Clark people. The Clark people are actually really good about things like this, and they should be able to help them out. If not, have them call me later.
You hear that, Volt? That was a great question. That sounds like a terrible issue you're having, and I can't even believe it's been an hour and 5 minutes. I've just been enjoying listening to you.
Yeah, it's been awesome.
So,
We
if people
definitely
do have
have you back on.
questions, would you want them to contact you with questions?
Yeah, oh yeah, sure. Yeah, no problem at all.
And so, what would be the best
How
way?
would they get
Email?
in touch with you?
I'm
Through
sorry.
email?
Yeah, email or call me. 678. If you want to write down my number, 678 687 1832.
That's it. Give them a buzz.
And yeah, I don't mind calls at all. And if you call in, and I'm in a pump room, I'll call you back just as soon as I can. You can also text me. Text me at that line. That's really probably a better way of doing it. Text me and send me pictures. I like pictures.
Okay.
So good stuff.
That's awesome. I mean, this has been great. So you're gonna have to come on again, because I feel like you got too much knowledge for 1 hour.
Yeah.
Well, I'd love to come back. So just invite me back, and just make sure that Sarah has some food waiting for me.
Yes.
Yeah. Oh, did she feed you good? What'd she give you?
Oh yeah, we got some gourmet sandwich.
Yeah.
Sandwich was great.
We don't get anything regular around here.
It was good. You don't know what you're missing, Bobby.
Yeah, I'm
Yeah.
coming soon. Oh, that's great. Oh, Volt says he's going there tomorrow at 6. So he's gonna figure it. This is Aaron. It's Aaron from HLE.
Okay.
So yeah, we had it seemed like the viewers were up. Everybody hit the like button before you take off. I'd appreciate it. Don't forget
Like and
to
subscribe.
subscribe, and if you want some merch, it's up here. It's up at the top. Dope dash and dash tape .myspreadshop.com. Get a hat like this. And yeah, we really appreciate you coming on and actually going to Brian's house. That's wicked cool.
Yeah.
All right, sounds good. So have fun.
Everybody,